Hello, I'm Annette Kirkland, and welcome to Beyond the Gates. In this season, we are talking about leading with innovation.
And our topic for today is From Dunes to Defense, Coastal Modeling for Military and Civil Works. And I'm with Leigh Langley. She is a research coastal engineer with the ERDC Coastal and Hydraulics Laboratory, also known as CHL. Good morning.
Good morning.
How you doing?
I'm good. How are you doing?
Doing good. So we're just going to jump in.
Okay.
Tell me a little bit about yourself and what you do at ERDC.
Sure, yeah. So, like you said, I'm a coastal engineer at CHL. My background is actually, I have a bachelor's and a master's in ocean engineering.
Very cool.
And so I have been working with ERDC for the last few years as a coastal physical modeler.
Nice.
Which I guess I'll explain as we go through.
Please do. Yes. I love it. This will be great. That's awesome. Physical modeling has been a cornerstone of ERDC's legacy, dating back to the founding of the Waterways Experiment Station in the late 1920s. Over the years, physical modeling has remained a key component of ERDC's research. What role did physical modeling play in supporting the United States during World War II, and how has it evolved to meet modern challenges?
Cool. Okay, that's a fun one to start with.
Yeah.
Let me start, I guess, a little bit by explaining, what physical modeling is. So, I mean, it's pretty self-explanatory, but it is physical, in-person modeling of real-life scenarios, whether that be at scale or at what we call prototype or real-world scale. And so, actually, there is a huge history in that at the Waterways Experiment Station, like you said. And so, part of back in the day, how they supported during the war was actually during D-Day operations. Yeah. And so engineers at the time, they were looking into the use of artificial harbors for joint logistics over the shore operations. And so they tested what was called the Mulberry Harbor caissons. And so they did that physical modeling testing, and from the data that they were able to get from those experiments, it actually helped inform where they could make landings in France during the storming of the beaches of Normandy. And so today, as we've kind of evolved, a lot of similar questions are still answered with physical models today. And just, as different coastal problems have grown in different ways based on, extreme weather impacts and things like that, and continued investigations into joint logistics over the shore, we basically upgraded our personnel capacity, our physical modeling capacity, learned ways to better represent, the coastal environment, and used all of that to continue answering those kinds of questions.
Super. That's great. That is awesome. Okay, so we're going to move on to HISER. Is that how you say it?
That's right.
So that stands for Hudson Integrated Coastal Engineering Research Facility. Explain how it works, what it is, how it works, and why its capabilities are so important. And then how does it tackle real-world problems?
Sure. Yeah, so I guess a little bit of background about, HISERF itself, where the name came from.
Yeah.
So it actually was named after Dr. Robert Hudson, and he was really an incredible engineer at the time who worked for Waterways and really did a lot of the foundational coastal physical modeling work. And he actually developed a lot of the equations that we still use today as coastal engineers. So one in particular, he developed the equation that we used for your armor stone sizing for breakwater. And all of that was done through experimental testing, so scale model testing.
Amazing.
And so the HISER facility itself really is what houses all of our coastal physical modeling capabilities. And I really want to, start by saying a big part of that is the HISERF team itself. So working out there, we have a team of engineers and engineering technicians, all just, incredible people with incredible skill sets. We have structural engineering backgrounds, mechanical engineering backgrounds, coastal engineering, ocean engineering, environmental engineering. So we really have this multifaceted team. That's great to be able to tackle these kinds of problems. But so within that facility, we have a large wave basin, what we call our HISERF basin, as one example on how we do coastal physical modeling. That's one of the facilities we use. And so what that is, we call it, it's Vicksburg's indoor beach.
Nice.
And so what it is it's basically just this large basin that we have a fully movable sand bed in there. And then we have a large series of wave generator machines. And so we can generate directional waves, multi-directional waves, waves at different angles, and we can get a really good representation of your nearshore environment. And so what that means, so if you've ever been to the beach and you go out and you start swimming, and all of a sudden your towel's like way down on the other end of the beach, and you're like, how did I get here? That's one of the types of things that we can replicate in there. So that's called longshore current. And so those types of currents, those types of wave interactions are all things that we can model. And so from a real world standpoint, how we use that to develop solutions is if we have certain coastal construction projects that are going to go in, we can model those in that facility and get a really good understanding of how that structure is going to behave, how the sediment's going to move around that structure. And we can also look at, things on like the vessel side, like how is a boat going to behave in the nearshore environment and all things like that.
Very cool. That is awesome. Very, very cool. So ERDC's CHL laboratory houses some really impressive wave flumes. What makes them state of the art?
Yeah, good question. So similar to the basin, we use them to replicate scaled or full-scale scenarios of different nearshore conditions. And so we have 2 flumes that are 208 foot long, so they're pretty heavy duty.
Huge.
And what we can do with them is really, we can generate any kind of, nearshore scenario. We can actually take, if we have wave data off of a buoy, we can take that time series and we can generate those exact conditions in our facilities. So cool. And so we can use that in a combination with, advanced measurement technology, laser equipment, motion tracking equipment, and we can build these scaled model experiments that we can use to investigate these different coastal problems, whether it be a breakwater, whether it be some kind of floating platform, really anything that comes across our desk is, we need an answer for this. We can replicate it.
Boom. That's cool. One of the most interesting things about ERDC's research is how it can be applied in so many different ways, supporting both military and civil works missions. Where does your work fit into that? Can you share some examples where high surface played a crucial role?
Good follow-up question to that. So I guess without getting too into the weeds in any in particular projects. So one example I'll say is, for instance, if there's going to be a new port or something developed somewhere and they want a better idea of, well, how is this change to that port system going to affect the port itself? Is it going to work how we expect it to, and it's going to dissipate wave energy coming into the port? Or is there something in the geometry that's designed that's going to have adverse effects that we don't realize? So say you're adding a structure and you end up getting reflection where you didn't think you would, and then suddenly you have a wave height within that harbor that's maybe twice what it's supposed to be because of that structure. Those kinds of things we can evaluate and see. So before anything even goes to construction, we can say, hey, here's where your problems are going to be, and we can eliminate that risk early on. And then same thing on really the military side. So a lot of, in the same way, what we look at is coastal solution protection. So how we can reduce erosion at the shoreline. And a lot of that comes with military installation resilience. And also still, like with the JLOTS operations, we can help use scaled model testing to help make informed operational decisions. So if there's a particular asset that we want to learn how it's going to behave in the nearshore, we can model that at scale and provide those answers.
It's really cool. Before you start.
Exactly.
That's huge. So I understand that ERDC's coastal modeling facilities are the only federal and DoD facilities with nearshore simulation capabilities. What makes these resources so valuable for solving complex coastal challenges? You've already mentioned, a lot of those, but anything else to add?
So like I said, I mean, the cost savings really is a huge part of it, is that we can build these things at a smaller, reduced cost, identify those risk areas. But what a lot of people also don't realize is when you move from what we call deep water waves versus shallow water waves, there's a lot of very different physics that occurs in that nearshore zone. And so being able to replicate that appropriately is really important to getting the right answers. And so with the latest technology that we have to be able to measure these types of scenarios, like we have a motion tracking system, so we can actually, if you've ever seen like the behind the scenes movies where they're covered in the ping pong balls and you can see where the little CGI figure is going. So we can pretty much do that with our models too. So we can put this object, in the near shore and then track exactly how it's going to behave. And that's really, really valuable to be able to provide that type of information to make decisions.
That is huge. Wave interaction with natural and nature-based features is a critical research focus due to its implications for coastal resilience. We've been talking about that, flood risk reduction, and habitat preservation. Leigh, how do CHL's wave flumes help us understand and enhance features like wetlands, mangroves, and reefs? And how does this flexibility help address research challenges?
Really good question. Yeah, so really on the coastal side, there's been a lot of popularity lately in looking into what you can call natural infrastructure. So things like you described, reefs, mangrove forests, things like that. And for good reason. A lot of it is, you get that added ecological benefit. You might be able to introduce certain types of habitats, like if you put an artificial reef somewhere, that might improve fishing in the area. And a lot of the times it's pretty aesthetically pleasing versus, just a traditional concrete structure. So a lot of what's started, people have been looking into really on the research side is, from a hybrid structure standpoint, like how can we start integrating some of these types of systems with our existing structures to maybe add some additional protection, potentially, increase the design life of some of these structures. But with that, there's still a lot of unknowns in how these natural infrastructure systems behave. And so what we're able to do is actually replicate a lot of that in the laboratory. So using field data, measurements of these types of systems, we can either build scale models or use live versions, and we can basically run different waves at them, and we can measure those waves and see, well, how does the wave energy reduce through that system? How is the sediment changing through that system? And then we can actually start to quantify the engineering performance of these types of systems so that we can integrate them more in our coastal designs.
Yeah, very nice. Very cool. Can you describe the ecosystem of a dune? Talk to us about dunes. Why are they so important?
Yeah, so with all of that, the natural infrastructure type solutions, coastal dunes are a huge part of that. And so, what a dune is it really is along sandy shorelines. It's really your first line of defense against coastal waves, coastal elevated water levels, wave impacts. And we've seen, data from that. There's been a lot of, post-hurricane assessments that have demonstrated that really billions of dollars in damages have been saved behind areas that were protected by dunes versus ones that may not have been. So a lot of what our research has been looking into is, well, how can we integrate more of those in our systems? And there is the Corps does a lot of sediment placement efforts, and that includes dune construction at times. And so what we really wanted to find out was, well, how are we making the most of how we're doing some of these construction efforts? And so, you look at a natural dune and kind of how they form really is you have this, embryo dune, we call it. And so you have some kind of starter vegetation, basically. And I'm not an ecologist, so they can correct me at some point. But so you have this kind of starter plant that traps sediment, windblown sediment. And that kind of triggers growth within the plant. And then the plant starts to grow. And then as it grows, more sand is blown into it and it traps that sand. And you just have this growth cycle that keeps continuing and continuing until you have this nice dune that's got vegetation kind of integrated throughout. So part of what we are interested in learning is, well, how does that natural dune, compare versus if you're just going to build a dune that's sand only? And so one of the ways that we used our flumes to investigate this, and hopefully I'm not running on too long about this because I do get excited about dunes.
Yeah, no, I love it.
So one of the ways, that we started looking into, well, how can we better understand the role of that vegetation is a set of experiments actually that originally was led by Dr. Duncan Bryant and Mary Bryant. And so they were some of the first to investigate, well, what if we used some kind of mimic vegetation to replicate real vegetation in the flume? And they built out these whole experiments with a dune and different levels of vegetation, found that really made an impact. And so we wanted to take it a step further and say, well, okay, well, how does the replicate vegetation compare to the real thing? And so last year we actually took a sample of a living dune and we put it in a box, and it was not a little box, it was a pretty big box, and we actually drove it back here to Vicksburg, and we put it in our flume so that we could test this living version of the system in our facilities and see how it actually compared to the experiments.
How'd it do?
It did really well.
Okay,
it did really well, and they did a really good job getting the parameters and the replicate vegetation correct, because a lot of what we saw was very similar response, which is good, because then we can use that to kind of understand, how we might want to design these systems in the future.
Yeah, super. What about mangroves? Can you just briefly, what's mangrove?
Yeah, so mangroves are really like a tree-like structure, and so they exist in a lot of the coastal United States, Florida, coastal, up into the North Carolina, Georgia. I think they're even starting to climb further north. But yeah, so coastal mangroves, there's a lot of interest there as well for similar reason, the potential and their ability to reduce incoming wave energy. Okay. And so we've done similar experiments with that as well. And we built a model. It was a 1 to 2 scale model mangrove forest. Okay. And it was, I think it was about 15 meters long. Okay. So I think by the end of the day, we had about 270 model mangroves, something around that we had built and put in our flumes.
That's amazing.
And so if you're listening, they're about my height. I'm not very tall, so they're about my size, and we have built like 270 of them.
That's amazing. I think one day I was pulling into work and saw them maybe for some reason, and I was like, what is that? I had no clue. They're like are they plastic?
Yep. So the ones that we modeled, trees. We actually modeled with PVC pipe. Okay, and so it turned out that at the scale that we wanted to represent them at, we follow a lot of, different scaling laws and how we develop these models, but it turned out that the deflection that was needed was actually really, replicative of PVC pipe at scale.
So cool.
And it got us the right answer to what the true, tree trunk should be.
Amazing.
Very cool. Yeah, that was a really fun experiment.
Yeah. I was like, what in the world is happening? What is that? Okay, partnerships. Always a key part of ERDC's work. With so many subject matter experts across different fields, collaboration seems to happen naturally, doesn't it? What's it like working in an environment where scientists frequently engage with each other's experiments?
Yeah, that's a really good question. I mean, for one, it definitely keeps you humble, for sure.
Yeah.
We work with really just some incredible folks, some incredible students, incredible faculty across different universities. And it's really valuable because a lot of these folks, they have really good relationships with the folks and, the field areas located near their universities. And so they're able to bring a lot of that expertise to their specific coastlines to us. And then we're able to combine that with our expertise to really build out a lot of, good physical experiments to help tackle problems along any coastline. And so it works really, really well. We're able to leverage a lot of those relationships to do things like that. And the other thing is we're able to get, a lot of good students involved a lot of the time. So we've actually had university partners that have worked here with us in our facilities, and they're able to bring our students that actually get to run their own experiments a lot of the time. And that's really great for us because we have obviously the extra hands in the laboratory, but it's really great for them because they get the hands-on experience being able to work with just state-of-the-art facilities to do their research.
No doubt. That would be such a blessing for me, being in college and doing that. With all these tests and experiments that y'all are doing, what's something new or unexpected that ERDC's research has recently uncovered about coastal processes that you can chat about?
Yeah, I mean, that's a really good question. And obviously, I want to say that a lot of the time we end up with more questions than we have answers. But I will say that I think with a lot of the vegetation work, especially on the dune side, that was one of, kind of the biggest things was, we expected that the vegetation would make a huge difference in sediment retention under wave action. But I don't think we maybe realized just quite how much of a difference it would make. And so when we did the most recent experiments where we actually compared the live dune to just a sand-only dune, we actually found that the sand-only one with no vegetation in it, it ended up, what we quantified in the experiments as failing, 3 times faster than the vegetated dune. Wow. So that has a lot of impact when, we're doing designs, because if we're able to find ways that we can, replicate that resilience, then that's a huge win, because that's a lot of sediment and that's a lot longer your dune might stand up in an extreme event and reduce your damages later on.
No doubt. That's huge stuff. Looking to the future, How do you envision the coastal physical modeling facilities at ERDC continuing to play a critical role for our nation?
Yeah, good question. Well, I mean, like we started, you asked about how we supported World War II and kept doing it. And I mean, we're still doing physical modeling today. And obviously, I mean, looking to the future, technology is continuing to advance. So obviously how we're, recreating these nearshore scenarios is getting more and more accurate. How we're measuring them is getting more and more accurate. But also computational, requirements are improving. And so looking towards the future, as more and more things are done computationally, there's still a lot of unknowns in how to do that, do certain nearshore problems with computers. And so as that technology develops, a big part of that is going to continue using physical models to validate a lot of those numerical models. And then, down the road one day, the good thing about that is once we do kind of get a lot of these things integrated, well, that can be a much faster way to make some of these decisions.
Very cool. Important work going on at the ERDC. And you heard that from Leigh Langley, a research coastal engineer with the ERDC Coastal and Hydraulics Laboratory. Thanks for joining me, Leigh, and thank you, listeners. We will be back with another episode next week.